Hi, this is Ray Rasmussen for Real Time with IPC, and in this special segment, we're going to be talking about print electronics. And my guests now are John Andresakis with Oak-Mitsui, and I'm going to call you Jeff Gordon, but you're not. Scott Gordon with DuPont Teijen Films, and I've got Josh Goldberg with Taiyo and Taiyo USA, right?
Taiyo America. Yeah.
And so we're going to talk a little about print electronics. We've been in a conference all day long, and we've been listening to speakers talk about all kinds of things. But to get started, I want to ask John to kind of give us an overview of where we stand with print electronics. He keeps an eye on it for his company. So John, if you wouldn't mind, just give us a little overview of what you've seen.
Okay. Well, every year there's a conference in Santa Clara called ID Tech runs their printed electronics show, and every year it continues to grow. The supply base continues to grow, new equipment suppliers, and so there seems to be a real interest in the area. Some applications, they do have some demos and stuff, and probably the area where taking that where that's kind of like where the products and materials come from. One of the applications that you see at the Society for Information display, and you see things like touchscreens. They're going away from the Indian tin oxide sputtered on glass to now, printing the grids onto films and flexible glass and things like that for touchscreens, and they're becoming prevalent. So that's probably one of the growing areas for printed electronics to bring costs down as well as improve performance and flexibility.
Okay, what do you see, Scott? What's out there? What do you?
Yeah, I agree. Printed electronics has been around for quite some time, and but it's growing and emerging applications. In addition to the shows that John mentioned, Flex Tech Alliance is an annual event, and the nice thing about all these shows is it seems to be an increase in attendees and exhibitors, and so that's always a sign of a healthy business. At the Flex Tech conference in February, one of the buzzwords was we're at a tipping point, and so that means that some of the technologies that have been developed and prototyped are approaching higher volume applications. We're still all waiting for the killer app type of thing, but it looks like it's going to be an incremental success story as opposed to the killer app driving things. At DuPont Teijen Films, from a substrate side, I agree. The touch panel sensors is an exciting area. We're seeing a lot of activity as traditional ITO on glass applications are shifting towards ITO on film, and or some of the ITO replacements on film, such as the silver nanowires and metal mesh, carbon nanotube applications. So yeah, it's an exciting time. I think we really think we are at a tipping point.
Good. How about you, Josh? What are you seeing out there?
Seeing a lot of development with materials. A few years back, the big buzzword was carbon nanotubes, and it didn't really take off because of the prohibitive cost, really. And now we're seeing some developments with graphene, trying to make that printable. One of the things too that there's a lot of work being done in is trying to incorporate these materials into things like, say, nanoparticle silver. So silver is something that's more of a variable cost type material dependent on the silver market. So if you put material that's more stabilized, like say a graphene in there to keep or even boost the conductivity of the material, and then it would make it or insulate it somewhat against cost variations in the market. But also there's a lot of development work being done, not just in the area of inkjet type printing, but more for like roll-to-roll type applications, anything from roller coat to gravure to flexo. And so a lot of these inks are being more tailor-made towards rapid application as well as rapid curing types of applications too. So.
Right. So again, we were in this conference today. We were listening to all these different presentations, and one of the presentations that kind of caught my eye was the presentation by Mark Carter from IPC, and talking about standardization and how the IPC is now working with a whole host of different groups around the world, trying to develop common standards. What he did say was interesting, I didn't know this, was IPC and JPCA are doing all standards for print electronics jointly, which was something new for me. But will that have, that kind of interest globally it seems like it's going to help this thing move forward faster. That we're going to be able to get the materials to a point where we can have confidence in them, and our customers, the end customers, can have confidence in them. But what do you guys think about that effort? I guess you're in the standards efforts here at IPC. So, anybody want to jump in?
Sure. We're seeing a lot of the global community coming together to make these standards, because not only is there a lot of research being done, but now the research is starting to move more towards startup base, and then some companies are actually adapting the newer technologies, and so there is definitely that need to be able to have some sort of established standard to be able to measure not just your device, but the materials you use against. And so it's good to see a globalization effort, not just JPCA, but also the governing body in China, as well as working with some of the governing bodies in Europe too, to try to make a overall encompassing set of rules and guidelines for printed electronics.
Scott?
Yeah, so the standards efforts are very important. There was an effort a few years ago funded by the Flex Cycle Alliance to develop a materials registry, and it was a valid effort, but it kind of stumbled for a few reasons. One of which was a lack of standards. People were submitting materials into the registry with differing values and differing ways of measuring the data. And so having IPC leading the standards effort here is very important. One of the challenges is having enough people participating in the development of the standards. And of course, we're looking for additional folks to help us in that effort. There's standards subcommittees on substrate materials, functional materials, design guidelines, and the like. And so we're always looking for additional help. And as Mark said in his presentation, Mark Carter, contact him if you're able to participate.
Yeah. How about you, Johnny?
Yeah, being kind of, even though printed electronics in one way, shape, or form has been around for a while, we have additional stakeholders now. And when we make standards for electronics, we pretty much know who the OEMs are, the supply base. It's very stable, but now there's people coming in from like the Gravure Association. There's other processes and things that we don't currently use in our part of the industry, but they're kind of stakeholders, and they have to get their input as well. So like any new technology, a lot of stuff is now agreed upon between user and supplier, and that's good enough for now, but to give some credibility to the technology, we do need to establish some standards and get all the stakeholders involved.
Yeah, one of the things that Mark also said, which I found kind of surprising, was that the IPC is leading the charge in some of these areas. I'm like, wow, we got out ahead of the crowd, I guess, so to speak. So that's kind of encouraging. People are looking to us to provide some of those material standards now. So that's a good thing, I guess, for us. Let's talk about the printed circuit board industry, something that is near and dear to most of us. I've always, I don't know how we're going to integrate print electronics into the printed circuit board world. I see it coming. It seems to me like a train, just coming. The headlights, you can see it off in the distance. And some people don't agree with me on that it's, print electronics aren't going to have that kind of effect on our industry. But in the meantime, Mark said that over the next 5 years, they really pretty much just see print electronics as sort of kind of a hybrid for the printed circuit board industry, that more and more fabricators will learn how to adapt and adjust and add print electronic technologies into their current offerings for their customers. And so if you guys wouldn't mind, what do the hybrids look like? John, why don't you start there?
Yeah, well, an easy example would be, integrating passive devices, let's say, into the board. You can, right now when we do integrated passive device, inside the board, it's just a tractive process. So we have the resistor layers, the capacitor layers, and we just etch the pattern, but the full sheet is a complete capacitor, complete resistor. So there's a lot of material waste in that, okay? So if you start doing it now additively, and you only put down the material where you need it, you could have a regular printed circuit board, but on those layers where they need the resistors, capacity, you just print it. So again, that way you could integrate it in, and that would be an easy way of doing it. So again, it's that type of hybrid, material.
Now, from my perspective as a polyester film supplier, a hybrid can mean going from glass-based display substrates to polymer-based substrates. Traditionally, LCDs are made with thin film transistors on glass, a lot of vacuum deposition. That's transitioning over to your polyester substrates, both PET and pen-based. They all have, both of those have limited processing temperatures. PET is about 150 C, pen about 200 C, which is well below typical semiconductor processing temperatures. But there's companies that are successfully developing and bringing to market shortly. Inorganic TFT backplanes on pen films, and then organic TFT backplanes on PET films. And so they're bringing the processing temperatures down. Meanwhile, the material suppliers are improving the mobilities to be able to compete with the vacuum deposited semiconductor materials. And so that seems to be a new area of high growth as there's a trend towards, again, film versus glass for thinness, durability, lightweight, and hopefully cost, ultimately.
How about you, Josh? What are you seeing? What are the potentials for hybrid systems?
Well, the nice thing about hybrid systems are that you can integrate the cost savings of printing part of it to established technology, like putting a printed battery into a flex circuit and having the whole thing be flexible as opposed to a rigid cell. Another way that you see some of the hybrid technology are in things like EL or electroluminescent lighting. A lot of it's printed, but there's still a typical deposition like the ITO on the flexible film, or even things like in the solar industry, looking at things like SIGS solar cells. They want to print that on a flexible substrate like a PET or a PEN, and you need some way to be able to marry the P-type and N-type semiconductor part to the substrate. And so having a printing type process on roll-to-roll where you marry the two together makes sense in something like that. And so it's a way that we can work towards driving down the cost, and it's established enough, at least with the printing technologies, the Gravure, Flexo, inkjet, that a lot of companies already have the type of infrastructure that they need to be able to move into printed electronics and create these hybridized devices. So.
Okay. Also, you guys were in the presentations today. Did anything jump out at you guys when you were anything new and exciting that you saw today in any of the talks, or is it pretty much? Go ahead.
Yeah. So one of the talks was from Solacore, and talking about the battery technology, and so that's kind of a hybrid. I think that's moving away from non-printed into a printing environment, but I was happily surprised at how close they are to taking the printed batteries, thin printed batteries, into credit cards for security purposes, for the changeable tokens. I've known that's been a dream of many in print electronics for a number of years, but I was not aware that it was that close to commercialization.
And that's what the batteries lasted, like, what, 3 years? Or
it's at least 3 years, right?
Yeah, amazing.
Mm-hmm. Right.
Amazing, just printed. Anything else jump out at you guys?
Well, I think because we've been going to so many conferences and stuff, I think we know a lot of what's going on. So I wouldn't say. I think what's good is the fact that we are having sessions on print electronics here at the IPC, so people who are not familiar with it can hear the state of what's going on.
Well, you said, oh, go ahead, Josh, sorry.
Well, I was going to also add to that too, not just that we're having sessions at IPC, but they're expanding. Now we've gone to 2 tracks for printed electronics, and also couple that with the shows and how they're expanding. I think it's showing that this is definitely an industry that's growing, not just in interest, but also in the amount of people willing to dive into it. So.
Yeah, in fact, we're seeing a number of exhibitors now, like Inscript and people like that had never exhibited before, now coming here.
Right.
So.
Well, speaking of Inscript, I was impressed by what he was talking about. He had a 3D print electronics kind of structure that he's already building, right? So that's coming. One thing you said, Josh, during the and I'm going to come to you in a minute, Scott, but you said that your company is collaborating with other people manufacturing components to help offset the cost, to help bring systems to the market. Can you elaborate on that for a minute or so?
Sure. With printed electronics, really in its infancy, in the early on stages, you had to pick and choose. You get a conductive from this company, a semiconductor over here, a dielectric over here, substrates from 2 or 3 different suppliers, and you just have to experiment. environment, and it was very frustrating because not all the materials are compatible. And so there's been a recognition from material suppliers that, you know what, companies can't specialize in all the parts, so why can't we team up with the specialist in a given area? If our company offers fantastic dielectrics, why can't we work with a company that offers fantastic semiconductors, and, you know, a company that offers fantastic conductors? And then if somebody can come to us and say, look, I'm making printed lighting, what do you have to offer? And then we can offer a materials suite to that particular company, as opposed to just say happy hunting. And so, you know, it's good not just for development of the industry, but it's also good customer relations too. It shows that you're willing to work with them to move their projects forward too. And so that's kind of where we're coming from.
And what Scott, one of the things you said earlier was, and it probably is connected to what Josh is talking about, and that's the cost. The cost of developing that. You mentioned this perfect printed electronic substrate. You can do this. DuPont can do it for, what was it, $100 million bucks?
Hundreds of millions.
Hundreds of millions of bucks. So we've got to come up with other solutions, and
yeah, so
it's just too expensive.
Right, and so that leads, you know, lends itself to, you know, making the best out of the existing materials. As I mentioned in the talk, you know, the perfect substrate could probably exist, but the market isn't big enough to justify the investment costs of putting in all the assets. And so, so we're working with, you know, speaking of collaboration with organizations like the Whole Center, where it's kind of an open innovation based out of the Netherlands, where you know, we're working on. They're doing some, you know, OLED-related things, and so OLEDs need barrier films, and barrier films are not cheap, and so and you need a really clean surface in order to do a barrier film. So we're working on a project to develop very clean films using a sacrificial layer that comes off at the end, but then, you know, someone needs to build a barrier on that, and then somebody needs to test it, and so we're kind of working as part of the you know, the Open Innovation Group to you know, to develop, you get the ideas, develop it, test it, and then hopefully bring it to market in the near future.
Yeah.
John, again, you talk about one of the things that was amazing is, like, when I went to, you mentioned OLEDs, and when I went to Society for Display, one year we're talking about OLED TVs. The next year I go, and both Samsung and LG have huge curved OLED displays, and it's amazing. You know, it's like, I know it didn't happen overnight, but, you know, they still have issues they have to work out on longevity and cost, but the fact that they did it, they showed, and it was a beautiful TV. It wasn't, you know, it was great. So so it's come a long way.
It just cost $100,000.
Oh yeah, but of course, but then the way that's the way regular LEDs started out that way. Plasma, you know, but it's amazing. The cost curves come down a lot quicker these days.
Yeah. And right now it's you know, it's vacuum deposition on glass, and that's trending towards you know, printing on film substrates, hopefully in the not too distant future.
You know what? And back to Mark Carter for just a second, and it dovetails off what you said, John. But that the associations around the world realize that they can't make things they can't create the standards quick enough to meet the market demand, market requirement. Things are moving too fast. They can't afford to do it, and they don't have the time and the resources to do it. They got to leverage. They got to work together, as Josh is saying. You know, the answer to printed electronics going forward is collaboration, probably.
Yes.
More and more companies learning to collaborate, put those product suites together, make it easy for people to move into this technology.
Yeah. The other thing too is, and maybe it's a little stretch, but I don't think so, is that we talk about killer apps, right? Where do a lot of these applications come from? We'd like to think they're going to come out of traditional America, you know, these are big technology companies, but guess what? They're going to come out of startups. Right. A lot of these ones, and because of these changes to the laws now with crowdsourcing and all the things that are doing to try to spur small businesses, that's going to help this industry. Right. Because a lot of these technologies, these wearable, you know, sensors and things are going to come out of university startups or people, and that's what's going to get things going. You know, and if we can put the infrastructure in place to support them, almost like, you know, printed electronic incubators, like the Whole Center, things like that, so that someone with an idea can go someplace and actually try it out, and then, you know, to build the business. That's going to help, you know, move it along.
And along those lines, there are several universities that are now shifting from their, you know, newspaper printing or other types of printing, graphics printing, into print electronics centers. There's probably at least 4 here in the U.S.
That's right,
today.
exactly. At least 4, yeah.
Nice.
So I think it's important for us all as suppliers to support those universities, and those folks coming out of them will hopefully be the next innovators and will develop the killer applications of the future.
Well, it seems like we just have to hold on. It's almost there. We're at the tipping point again. We're at another tipping point, so it's exciting. Gentlemen, thank you for stopping by. Thank you for your efforts in this industry. Thank you for your work on the standards and stuff. That's important. Again, we've been talking about print electronics. I got John Andresakis here. I've got Scott Gordon and Josh Goldberg. So thanks for watching.